Good morning, ladies and gentlemen. I place my gloves. Good morning. Good morning. My topic for this morning is a long video format topic, and it is one of the topics on the playlist, mixed topics. So this is regarding electronics. What I will be discussing this morning is the usage of an ATX power supply to power up a small inverter. This is a 200 watts power inverter. This is actually a car inverter. Meaning to say, if we needed an alternating current in our car, we'll just plug in this cigarette lighter here. And if we want to charge a cell phone without using the USB, we could plug in here. And of course, the output of this one is alternating current because it's an inverter. If this is on, the plug-in thing will be energized. So what did I do this morning? So I brought out my ATX power supply, which myself presented another video blog of mine. This is done. I will try to bring out the characterization of this ATX power supply, which I did it myself. The output voltage of this one is actually 4 voltages. The first one is 12 volts. The second one is 3.3. The third one is 5 volts. And the last one here is actually 12 volts. To use this one to power up an inverter is a machine in which it will convert direct current to alternating current. So the needed power supply of this inverter here is actually direct current. The input will be here, right? So when we try to inject voltage here, the inverter will be alive, and anything that we plug in here, because the output voltage of this one is 120 volts. I am here in the USA right now, Los Angeles. So the output voltage of this one will be 120. So any gadget that will be plugged in here that requires 120 volts will be energized, for as long as it does not overload the inverter. So for small charging applications like this one here, this is a what you call this a charger for a cell phone. I use this one to power up my assembled FM radio. Okay, so for this radio here to operate, the input voltage here should be 120, right? And what comes out here is 5 volts, and that will be the one that will power up my assembled. This is my assembled FM receiver. So I will be using this FM receiver as a load to the inverter. Okay. So what do we do? I place the connection now. This portion here is on the ground portion of my ATX power supply, and this pointed thing here is the positive supply. So this is ground, connected to ground here. This pointed thing here is connected to the voltage requirement of the inverter is actually 12 volts. So I will be using the first terminal, this one here, first terminal. Okay. Then I connected in series with the 12 volts. I connected in series an ammeter or a multitester set to amperes. because I would like to monitor the current coming from the ATX Power Supply just to energize this power inverter here. So what will I do? This is the plug of the ATX Power Supply. So if I will try to power on this one now. Okay. I will now press the load on the inverter. Okay. I'll plug in here. This is the 120 volts output. Because just in case the inverter is energized, okay, this will be alive, and what comes out on the convenience outlet here is actually 120 volts. This is 120 volts. So I will now plug in the supposed to be load that I will be showing to you. Okay. Right? Or let's try it. I will try to energize the ATX power supply, and let's monitor the current coming from the ATX power supply to be injected on the power inverter. Then later on I will try to flip on the switch here, okay, to make this receiver alive here. There's no current consumption yet, okay. The voltage injected on the inverter is 12 volts. So I will now try to flip on this, I will try to flip on the switch. Okay. This inverter here is alive. And the power supply going to the radio is actually 120 volts, and let's try to scan the frequency. So it's working. Okay, it's working. We energize the ATX power supply. Okay, we energize the ATX power supply, and the current consumption now is 0.338 amperes. This inverter here is alive. You see the green light here. Okay, and since the inverter is alive, of course we plug in the radio will be alive. So what we needed here to energize this radio here is 120 volts, because this is what we call this adapter for the power supply of the FM radio. Okay, it's working. The current consumption now is only 0.36 amperes to make this inverter alive. So just in case you are in your car and you needed to charge your battery, if you don't have any USB connection there, you will plug in this, what you call this, cigarette lighter here. On the cigarette lighter, the plug for the cigarette lighter, and the inverter will be alive. So if you need to charge your battery by using a USB charger, it is this. Right? I will try to remove this one. As you can see it, the inverter is alive, right? And I will now place the load, okay? I will plug in this one. Okay? The FM radio that I assembled is actually alive. So I will try to scan the frequency now.
NMLSConsumerAccess.org, number 3030.
It's very clear.
Don't postpone.
No interference.
Shop Mattress Firm's
Okay.
Memorial Day sale now.
So this is an application.
Curated selection and take your
This is an application of an ATX power supply energizing an inverter, and this inverter energizes this voltage regulator here, or adapter, to power up this FM receiver here. So if you want to charge your cell phone, you can charge your cell phone here, right? Because this thing here is actually a USB connection. But for this radio here, the voltage requirement is same as for the cell phone. That's why I utilize this, what you call this, charger here to energize my FM radio. You see? The current consumption is only 0.25 amperes to power up this inverter here. This is 200 watts, And supposed to be, this is a sine wave inverter. So we could power up our electronic gadget here without damaging them. Because just in case the wave of this one is a square wave, it will be destructive to any digital thing that you will plug in there. And since this is a sine wave, okay, this is compatible with anything electronic like 60 Hz frequency, sine wave, so it is compatible with electronic equipment. Because just in case this is a square wave, you will be hearing a humming sound just in case you plug in anything. You will hear a humming sound if this is a square wave. Meaning to say, the wave that goes inside the circuitry is not a perfect sine wave, not a perfect sine wave. It is a square wave, that's why there was a humming sound. And since there is no humming sound here, it means to say that the power output of this one, the wave of the current and voltage is actually alternating current. And it is compatible with digital circuits. Okay, I will try to increase the volume. It's working. So, I'm utilizing the output of this one as 120 volts to power up this, what you call this charger here. The output of this charger is 5 volts, same as for the cell phone. That's why this is actually a charger for cell phone. Okay? The power input is actually 120 volts. And what comes out here is 5 volts. Because when I assembled my FM radio here, the voltage requirement of the FM radio is actually 5 volts. So it is compatible with this one. Okay, I will try to increase the volume. Working.
Find the right person fast. 4 out of 5 employers
Working.
post on ZipRecruiter get a quality candidate
Okay.
within the first day. Try ZipRecruiter for free.
That's it.
At ZipRecruiter.com
An ATX Power Supply,
That's
energizing an inverter,
ZipRecruiter.com/free.
and this inverter energizing what you call this, a charger, and this charger actually activates this symbol FM receiver,
Does the same.
right?
Offers the professional grade products.
And the current is only 0.25 amperes. So my 300 watts ATX power supply will not be more than good enough to power up this one, even though for a long time maybe. This is 300 watts, and this one only represents maybe a 5 watts or 2 watts. So we could use this one just to play something on the radio by using this inverter here. That's it. Okay, I will try to summarize. An ATX power supply, I utilize the 12 volt line to energize the inverter, and this inverter was alive, and when the inverter is alive, it energizes this, what you call this, voltage charger of a cell phone. But luckily, the power to my radio also have a 5 volts, so this is compatible with my radio. Okay? Okay, stop it. Yeah, that's it. That's how it works. An ATX power supply, I utilize this one to energize this inverter, and this inverter is alive, and this inverter make this, what you call this charger alive, and when the charger is alive, of course, anything that is placed as a load on the charger, okay, will be energized. Okay, I will repeat one more time. I will try to click on the inverter. So it's working. The current is only 0.25 amperes. Okay, good morning from Los Angeles. This is Professor ProfDavidJDelosReyes.
He'll never stop doing.
Good morning.